Okay, we are going to try and record this video and hopefully it turns out okay because my computer is glitching a bit. So I'm going to run through kind of what we are going to do in class tomorrow. Um, so today we talked about similar polygons and determining whether two polygons are similar. We know that they have to have the same angle measures and the sides have to be the same scale factor. Um, this is going to be one of the ones that we do later. So this asks, are angles enough? Well, we know yesterday that we were able to look at two rectangles that had the same um four right angles, but the scale factor between side lengths were not the same. So if I did 2 and 2 here, to go from 2 to 8, I'd have to do times 4. 2 to 4 is times 2. These are not similar. If I have the same angles, this is keeping the same angles with trapezoids. It's keeping my angles the same, um, but just allowing me to make it larger. Trying to get 4.4 up top. Okay, so I got 4.4 up top, so that would be times 1/2 to get the smaller trapezoid, but it would not be times 1/2 to get the other side lengths. So knowing the angles are the same is not enough information in these two examples. However, the angles being the same is enough information when we talk about triangles. And that is our focus today, is looking at the measurement of triangles. So drag movable points to create a triangle with the angle measures 40, 55, and 85. So an angle measure of 40. Hold on. There's my 40. 85 and 55 right there. So do I think that we all made similar triangles? So if we all used the same angle measures, we should have similar triangles. So this is gonna show using our rigid transformations and dilations to match them all up. So when I click try it, all of these triangles have the same angle measures and they rotated them, reflected them, translated them to get them all to match up. And I can use the scale factor here to show that all of these are similar. I can multiply by the same scale factor here. Okay. But if I was only given one angle, that would not be enough information. So if I match up all the 40-degree angles among all of these ones, notice that these no longer are parallel lines, and that's going to be what's important is your side lengths have to be parallel. When you dilate a shape, your corresponding side lengths are parallel. So this one right here, if I can match it up, is similar to mine. But that's the only one that matches up with mine. Okay? Um, so we'll do that in class. We'll do that in class. So here this says describe how you can use angles to determine whether triangles are similar. If I was to match up A to B, match up my 50-degree angle, it would make a parallel line through here. And that's when we want to use our parallel lines and transversals to prove congruency of these angles. So this would make a parallel line. This would become 60 degrees. It would show that that is the same measure. Because I only need two angle measures in a triangle to figure out the third, I would be able to figure out that this angle measure here is 70 degrees. And then I can dilate this small triangle to meet up with E and F. So lastly, with these ones, it gives us two angle measures. As long as you have two angle measures in a triangle that are the same, you can prove that they are similar. So triangles are different from other polygons. Triangles are the only shape that you can prove similarity with only the angle measurements. Okay? If you have any questions, let me know. We will work through this Desmos and another Desmos tomorrow.